right? Then, so let us take the problem on integral 1 to infinity tan inverse x by x square dx. So let us discuss about this problem. Now, if you consider this, we are going to write it as limit t tends to infinity integral 1 to t tan inverse x by x square dx. Now, any guesses how to solve this problem from anybody? Since we have come across so many methods with regard to integration, what are the procedure we can do here? Right, integration by parts. Apart from this, can we do any substitution method? So I want to say here that you can choose the part as you put x is equal to tan theta, then dx is equal to secant square theta d theta. That you can do. So substituting these values here, if you consider the integral 1 to t tan inverse x by x square dx is equals to, so it will be, so apart from considering the limits, you simply take like this, the integration. First we do the integration, then we substitute the limits. So it is equal to integral theta by tan square theta into secant square theta d theta. Now simplify the part. So tan square theta is nothing but sin square theta by cos square theta. So cos square theta gets cancelled. So it will be integral theta into cosecant square theta d theta. So if you do the integration, it is nothing but, now here you are going to do the integration by parts. Am I correct here in taking the values? You can check for the same answer by doing integration by parts also. You can apply the formula I let and you can do the integration. Otherwise, you can do this substitution part. That is also comfortable. So converting this into in terms of x, it is nothing but, for cot theta we take 1 by x. Theta is nothing but tan inverse x. So minus tan inverse x by x. And for log sin theta, its value is nothing but log of x by root of 1 plus x square. How this value came? Because we have x is equal to tan theta. So this implies x into cos theta is equal to sin theta. We should know the value of sin theta. So x by secant theta is equal to sin theta. So x by root of 1 plus tan square theta is equal to sin theta. And you have taken x is equal to tan theta. So it will be x by root of 1 plus x square. That was the value. Okay. Any questions, please? To anyone? Now we do the limit part here and we go for the substitution of upper limit minus lower limit. So here if you consider the limits here, integral 1 to infinity tan inverse x by x square dx is equal to limit t tends to infinity. So for this part you are applying upper limit minus lower limit. So minus tan inverse t by t plus log t by root of 1 plus t square minus tan inverse 1 by 1, or you can take minus outside a time. So if you substitute the limits, then you are going to get the value as, I will say, log 1 plus pi by 4, then 1 by 2 log 2. And the value is pi by 4 plus 1 by 2 log 2. You can check for that. Other terms gets cancelled and the values are 0. So since I am giving the procedure part, it is simply doing integration. On paper you check for yourself whether we are doing right or wrong. So my advice is simultaneously you do the problem which are easy. For the difficult one I will give the advice. And confirm me the limit part. So you have one question that if you have log of 1 by root 2, that you can write it as log of root 2 power minus 1 or 2 power minus 1 by 2. So minus 1 by 2 log 2. That you can write it like this. If you have any doubt for this one. Is it clear now? While applying the roots and limits. Right. So after the simplification and applying the limit, the value is pi by 4 plus 1 by 2 log 2. However, if you don't know how to simplify this, you simply leave like this, log of 1 by root 2. No wrong at all. There is no need to simplify this part because you know definitely it is nothing but a number, a finite value. If you want to simplify, you can simplify like this. Otherwise, there is no need to simplify. You keep this value as it is. So pi by 4 is a finite value, log 1 by root 2 is a finite value, hence the result is a finite value. Therefore, the given integral is convergent. On the whole, in exam point of view, you can expect the question pattern as test the convergence of the integral. Every question generally will be given like that. Test the convergence of the integral. Usually question will be posed like that. Okay? Right. So can I take the other one? Please take a note of it. So the other question is integral 0 to infinity e power minus root x dx. That was the problem. So we write it as limit t tends to infinity, integral 0 to t, now we are going to do the necessary substitution. So you take that root x equals to z, so it is nothing but x equal to z square, so dx is equal to 2z dz. Since x is varying from 0 to t, so z will vary from 0 to t square, 0 to root t, because root x is equal to z. So this is equal to limit t tends to infinity, integral 0 to root t e power minus z, and dx is nothing but 2z dz. And you have the value for z into e power minus z, the integration value, limit t tends to infinity, 2 into minus z into e power minus z minus e power minus z between the limits 0 to root t. Now you can apply the limit parts there. So this equals to limit t tends to infinity, 2 into, you can substitute the lower limit as well as upper limit, minus root t into e power minus root t minus e power minus root t, and if you substitute 0, minus 1. So please apply the limit part as t tends to infinity. And give me the limit value. And one interesting thing here is, while applying the limits, you can apply L'Hospital rule also. That also you can do. You can apply L'Hospital rule while applying the limits. So by applying limit t tends to infinity, you please give me the value. What is the limit value there? So any doubts for anybody while applying the limit? You please tell. If not, give me the final answer. So is that minus 2 or plus 2? Yeah. While applying the limits, it will be plus 1, right? You are going to get the value as 2 plus 2. Accepted? Right. So since the limit value is finite, the given integral is convergent and the integration value is nothing but 2. That is the conclusion. If anybody has any doubts, you please tell. I will go with the modification. Okay. So can I take the other one? Right. So far we have taken the problems with infinity as upper limit. Let us take some problems with infinity as lower limit. So the problem, you can take it as integral minus infinity to 0 dx by t square plus q square x square. So the procedure is as usual. Apart from taking t on the top, we take t at the bottom. So it is equivalent to limit t tends to minus infinity integral t to 0 dx by t square plus q square into x square we will take. Now how to simplify this? You can take q square as common here. So this is equal to limit t tends to minus infinity integral t to 0 dx by q square into t square by q square plus x square. So it is of the form a square plus x square. So the integration value is nothing but 1 by a into tan inverse x by a. So this is equal to limit t tends to infinity. So 1 by q square is a constant here. So 1 by a is nothing but 1 by p by q into tan inverse x by a means x by p by q between the limits t to 0. Now in place of x, you are applying the upper limit 0 and as well as lower limit t, and t tends to minus infinity here. So you apply the limit part and tell me, and I will say that you are going to get the value as minus 1 by pq into minus pi by 2. You please check on that. So upper limit value you are going to get it as 0. For the lower limit you will get the value like that. I think tan inverse of minus infinity will be minus pi by 2. Am I correct? You confirm the limit part. Since the value is a finite number, the given integral is convergent. That is the conclusion. So do you agree with the answer? Right? So the answer is pi by 2pq, which is the finite value. So the given integral is convergent. So let us take the other one as integral minus infinity to 0 sin hx dx. So you try that problem now. As we know, sin hx is nothing but e power x minus e power minus x by 2. You take the part. Simply applying the limits, limit t tends to minus infinity. That equals to limit t tends to minus infinity, integral t to 0, e power x minus e power minus x by 2 dx. I think you can solve this problem on your own. However, I will give the limit part. You please check that the value is going to be minus infinity or not. After doing integration and applying the limits. Take your own time, then we will discuss. Once you get the limit, you please inform me. So is the value correct, minus infinity, the limit part? Since the value is not finite, the given integral is divergent. In other words, the convergence of the integral is divergent. Right. So if you consider the exam point of view, majority of the questions are posed from some number to infinity, 0 to infinity, 1 to infinity, 2 to infinity. You will expect majority of the problems under improper integrals where the integral sign is given as upper limit. For lower limit, we have less priority when compared to the problems. So at the most, we can expect the problems of this type. Lower limit is minus infinity, upper limit is some number. Now the interesting thing is, if both limits are undefined, how to do that? Let us go with that problem. So the first problem, we are going to take it as, it will be integral minus infinity to infinity dx by e power x plus e power minus x. That is one problem. And the other one you can take it as integral minus infinity to infinity dx by 1 plus x square And one more thing, integral minus infinity to infinity dx by x square plus 2x plus 2. Let us discuss about these problems. The procedure here is given as, generally, whenever minus infinity to infinity is given, we have to split the integral. So the procedure is given as minus infinity to a plus a to infinity, where a is a number lying between the things. It is taken as arbitrarily. Now what happens? Generally we take in the splitting a as 0. Because when one of the limits is 0, it is very easy to apply the limits. The limit part will be easy while the calculation. Accepted? So whenever minus infinity to infinity is given, we split the integral as minus infinity to 0 plus 0 to infinity, and we do the remaining part as it is. Clear to all? Any questions? So if you take the second problem, dx by 1 plus x square is nothing but tan inverse x. So this will be taken as integral minus infinity to 0 dx by 1 plus x square plus 0 to infinity dx by 1 plus x square. And evaluation of these integrals is similar as per the previous method. So it is equivalent to limit, since you are going to take t tends to infinity, since we have two integrals, you can use the two symbols if you evaluate them separately, or if you are evaluating them simultaneously, then use t1 and t2 for the limit part. So limit t1 tends to infinity, integral t2 minus infinity, t1 to 0 dx by 1 plus x square plus limit t2 tends to infinity, integral 0 to t dx by 1 plus x square. So limit t1 tends to minus infinity tan inverse x between the limits t1 to 0 plus limit t2 tends to infinity tan inverse x between the limits 0 to t2. That thing we will do. So if you apply the limits, you are going to get the value as pi. Please check on the limit parts. I am leaving that part for you because it is easy for you, the calculation of the limit substitution. Because for one integral, for the first integral you will get minus of minus pi by 2 as the limit value. For the second one you will get pi by 2 as the limit value. So pi by 2 plus pi by 2, pi is the answer. You please check that. I think it will be interesting to you if you do the problems simultaneously in the class. There is no need to go for a separate practice on it. So if you once confirm the answer, then I will go with the next one. So the limit is pi, which is a finite value, hence the given integral is convergent. So I think everyone has got the value pi. Anyone has any doubt? So all of you agree with the limit? right? So if you take the first one, so we take the simplification as it is, limit t1 tends to minus infinity, integral t1 to 0, dx by e power x plus e power minus x, plus limit t2 tends to infinity, integral 0 to t2, dx by e power x plus e power minus x. And while doing the evaluation, we will do like this, limit t1 tends to minus infinity, integral t1 to 0. So multiply numerator and denominator with e power x. So we will have e power x by e power 2x plus 1 dx plus limit t2 tends to infinity, integral 0 to t2, e power x by e power 2x plus 1 dx. Now why we are doing this? Because if you put e power x is equal to z, then e power x dx is equal to dz, and you will give the respective limits. So how it will be? Limit t1 tends to minus infinity, integral t1 to 0. So the value will be dz by z square plus 1, limit t2 tends to infinity, integral 0 to t2, same dz by z square plus 1. So here the integration is nothing but tan inverse z between the limits, and you are going to apply t1 tends to minus infinity and t2 tends to infinity. If you have any other approach, you can tell while doing the integration. The procedure what I am describing here is not unique in doing the integration. You can go with the other method too. I have taken some method which are useful for many of the times. Can you give any other procedure for doing this kind of integration? E power dx by e power x plus e power minus x. So tan inverse z is the integration value and z is nothing but e power x. So while applying the limits, you will get the value as limit t1 tends to minus infinity, tan inverse e power x between the limits t1 to 0 plus limit t2 tends to infinity, tan inverse e power x between the limits 0 to t2. So once you substitute the limits, then apply t1 tends to infinity and t1 tends to minus infinity, like that. If it is easy for you to evaluate the integrals separately, you can do them separately. Only one t we will take. Apart from having a confusion like t1, t2, etc., you simply take t. So evaluate the first integral, then evaluate the second integral. If you want to do them simultaneously, you can make use of t1, t2 separately. That's it. So if you apply the limit part, so you are going to get the value as pi by 4 minus tan inverse 0 for the first one, and for the second one, tan inverse infinity minus pi by 4. So however, if you take the value is nothing but pi by 2. Since it is a finite value, the given integral is convergent. So you please confirm the process and confirm the limit value. Then I will take the other one. Because I feel it is better that if you do the problem simultaneously with me, you will get the idea of solving the problem, apart from simply writing on board. So one of our friends has given the value as pi by 2. Let us take the confirmation from others too. So if you confirm the answer pi by 2, then I will go with this problem. Right. So for the third one also, we go for the split minus infinity to 0 and 0 to infinity. And the integration is very simple because this part can be written as do you accept the denominator part? Yes or no? So for this, the integration is nothing but tan inverse x plus 1. So it is nothing but limit t1 tends to minus infinity integral t1 to 0 dx by x plus 1 whole square plus 1 plus limit t2 tends to infinity integral 0 to t2 dx by x plus 1 whole square plus 1. Now for this, limit t1 tends to minus infinity, tan inverse of x plus 1 between the limits t1 to 0 plus limit t2 tends to infinity, tan inverse of x plus 1 between the limits 0 to t2. The rest of the part is nothing but simply applying the limit and give me the solution. I say that the final answer is going to come as pi by 2 plus pi by 2, nothing but pi you are going to get after applying the limits 0 or pi by 2, pi. Because it is tan inverse of x plus 1, if you apply the upper limit 0, so tan inverse 1 it is nothing but pi by 4. It is tan inverse of t1 plus 1, so tan inverse infinity you will get, tan inverse of minus infinity here. It will be pi by 2, right? Similarly for the other you will get pi by 2. Accepted? Right. So the solution limit is nothing but pi, which is a finite value, hence the given integral is convergent. So far, if you conclude our previous class discussion and this discussion, the total improper integrals what we have considered are of the first kind. What is meant by first kind? If you consider the integration limits, either one of the limits is unbounded or both the limits is unbounded, right? That is the only thing you have considered. There are two more kinds given in improper integrals. The second kind is the interval is finite, but the function is undefined at some points. Now we are going to take some problems on the second kind of improper integrals. So do you have any queries with regard to the first kind improper integrals and the solution approach to anyone? Right. So let us begin with the second kind improper integrals. That is, interval is finite, but the function has discontinuity or the function is undefined at some points. So let us take some problems initially, then we go with the other. Let us take integral 0 to 1 dx by root x. And you can take the other one as integral 1 to 2 x by root of x minus 1 dx. And some you can take it as, I think these two are enough for you at now. Let us take these two things. So if you observe that whenever the interval is finite, here the first point or the last point, sometimes both, will be the points of discontinuity. So in majority of the cases, either the lower limit or upper limit in the integral will be the point of discontinuity. So if you observe here, 0 is point of discontinuity for the function 1 by root x. Accepted? All of you? Because 1 by root 0 is undefined. So it is just like applying the limit as it is. The only thing we do is, while considering this integral, we will apply the limit as limit epsilon tends to 0 plus integral. So here 0 will be replaced with 0 plus epsilon. So you can take it as 0 plus epsilon to 1 dx by root x. So this is the modification we do in the calculation of integral. So this equals to limit epsilon tends to 0 plus, the integral is nothing but 2 root x, so epsilon to 1. So limit epsilon tends to 0 plus 2 minus 2 root epsilon. And after applying the limit, what is the value? 2. Since 2 is a finite value, the given integral is convergent and it is the solution of the integral. Okay? Is it clear to you? So earlier we will write it as t1 tends to infinity or t1 tends to minus infinity, and the lower limit or upper limit will be replaced with necessary t1 or t2. Here we are using the symbol epsilon. And while beginning the problem, we mentioned that 0 is the point of infinite discontinuity. And here you have only one point here. Sometimes you will get 2 points of discontinuity. So while taking the lower limit as the point of infinite discontinuity, we use limit epsilon tends to 0 plus lower limit plus epsilon we take. If the discontinuity is occurred at the end point, in such cases we take that limit epsilon tends to 0 plus upper limit minus epsilon we take. Suppose 1 is the point of discontinuity, let me say. So limit epsilon tends to 0 plus integral lower limit to 1 minus epsilon in the upper limit place, and we do the same thing. Okay. So if you take the second problem, so here 1 is the only point of discontinuity here. So if you consider the integration as it is, it equals to limit epsilon tends to 0 plus integral 1 to 1 plus epsilon to 2 value. For this we do the integration as x minus 1 plus 1 by root of x minus 1 dx. So this is equal to limit epsilon tends to 0 plus. Separating this, for 1 you have 1 plus epsilon to 2 root of x minus 1 plus integral 1 plus epsilon to 2 1 by root of x minus 1 dx. So if you go with the integration, limit epsilon tends to 0 plus, so here it will be x minus 1 whole power 3 by 2 by 3 by 2 and here 1 by root x, integration is nothing but 2 root x. So 2 root of x minus 1. So the limits 1 plus epsilon to 2 we will apply. That was the thing we do in the calculation of the limits. So if you apply the limits, you are going to get the value as 8 by 3. Please check it and confirm to me. Since 8 by 3 is a finite value, the given integral is convergent. And occasionally, while doing the infinite discontinuity problems under improper integrals, for majority of the cases, we will get the functions involving log terms. And sometimes they look complicated also. So generally, for such type of problems, one useful formula is there, that is limit x tends to 0, x power n into log x equal to 0 for all n greater than 0. Please take a note of it. We will make use of this formula for many problems. Right? Now, let us take some of the problems. The first one is integral 0 to 1 log x dx. The other one is, you can take it as integral 0 to 1 by e dx by x into log x whole square. Let us take these two problems for convenience. So let us consider the first one, integral 0 to 1 log x dx. Now what is the point of discontinuity here? 0. 0 is the only point of discontinuity for the function log. Accepted? Right. So let us evaluate the limit as it is. So for the first one, it is equal to limit epsilon tends to 0 plus integral 0 plus epsilon to 1 log x dx. This is equal to limit epsilon tends to 0 plus integral log x is nothing but x log x minus x between the limits epsilon to 1. So if you apply the limits, limit epsilon tends to 0 plus, so 1 into log 1 minus 1 minus of epsilon into log epsilon minus epsilon. Accepted? So this part, the limit is 0. Since limit epsilon tends to 0 plus, this value is also 0, and using this property, this value is 0. So the limit is nothing but minus 1. Since minus 1 is a finite value, the given integral is convergent. That was the solution. Okay. Now for the second one, here also 0 is the only point of discontinuity for the function. So what happens here? You can write it as limit epsilon tends to 0 plus integral 0 plus epsilon to 1 by e dx by x into log x whole square. So if you take that log x equal to t, then 1 by x dx is equal to dt. So it will come like limit epsilon tends to 0 plus integral epsilon to 1 by e, so t power minus 2 dt. This is the value. So can you apply the limits there? I will say you are going to get the limits as minus of -1 minus 0, which is equal to 1, which is a finite value. Please check for that. And t is nothing but log x. So log 0 is undefined, right? So I want to say that while applying the limits, if you put minus outside, this is the thing you will get, right? Say. And how do you simplify this part? Log of 1 by e. Log 1 minus log e you have done, isn't it? Log 1 minus log e. So that -1 you will get here. Yes. So minus of -1 you will get for this part. And for this part its value is 0. Because if you say as epsilon tends to 0, log 0 is undefined, it is infinity. So 1 by infinity is 0. It was taken like that. Log 0 is infinity. So 1 by infinity is 0. So the value is 0. Accepted? So the limit value is 1, which is finite. Any other confusion over this problem? So the other one is integral 0 to pi by 2 cos x by root of 1 minus sin x dx. Please take a note of this problem. Now you should tell among the two points 0 and pi by 2, which one is the point of discontinuity? 0 or pi by 2? Which one is the point of discontinuity? 0 or pi by 2? Pi by 2. So you are going to write it as limit epsilon tends to 0 plus integral 0 to pi by 2 minus we will write. So for the lower limit plus epsilon we will write. Here upper limit minus epsilon we will write. That was the modification. So it is cos x by root of 1 minus sin x dx. So if you take that 1 minus sin x equal to t, it implies minus cos x dx is equal to dt. So for this you can take it as, I am not changing the limits, it will be 0 to pi by 2 minus epsilon. Since you require minus cos x dx, one by root 2 dt minus comes to the out. So it will be minus limit epsilon tends to 0 plus 1 by root is nothing but 2 root t. So t is nothing but 1 minus sin x between the limits 0 to pi by 2 minus epsilon. I think it will be easy for you to calculate the limits. So please check it is minus 2 or plus 2. Because while applying the upper limit, its value is 0. For lower limit, you will get minus 1. So minus of minus, you will get plus, I hope so. The limit value will be 2, I think. So please check everyone. Now, one interesting question is, whatever the integral you take, either first kind or second kind, that is, interval is finite or interval is infinite, whatever the case you take, you are simply evaluating or testing the convergence of the integral by simply taking the limit, either limit epsilon tends to 0 or limit t tends to plus or minus infinity, isn't it? That is the only thing we are doing. Yes or no? For the improper integrals case. Accepted? So far, on thinking about the every problem, what we did and what is the approach? Simply we do, whenever the interval is infinite, we take t tends to infinity or minus infinity. Or we split the integral to the same procedure. If interval is finite, we take the point of discontinuity. So we take either plus epsilon or minus epsilon and we apply limit epsilon tends to 0. That is the only thing we do. And one interesting thing is, for every problem, the integrand is integrable. In other words, we know the primitive of the function, the integrand. Integral sin x, integral tan x, integral cos x, integral secant x, integral 1 by x, all these formulas are known to us. Now the thing is, I have given a finite interval AB, I have given a function f of x dx. I know the point of discontinuity is either A or B, sometimes both, but I don't know the integration of f of x. In such cases, what happens? You cannot apply limit epsilon tends to 0. Because if you apply limit epsilon tends to 0, for this function, you should know what is the integration value. Otherwise, you cannot simplify the part. Accepted? Are you getting the idea what I am saying? So, in such cases, means if you don't know what is the integration value of the function given in the integral, we make use of some tests, which are nothing but the comparison tests, we say. You can just remember the infinite series, where we use the limit comparison test, right? Both series either converge or diverge together. We do the same thing here. We will take another function. We consider the limit part. So both integrals either converge or diverge together. So we are going to use the concept of comparison tests as and when the integrand integration value is not known to us. Clear? The purpose of this comparison tests. Now I will list out the formulae and how to do the procedure. You please take a note of them and we will go with the problem solving sessions. Clear? Right. So the thing is, you are going to evaluate integral a to b f of x dx and assume that at a we have discontinuity. Let us assume that a is the point of discontinuity. Please understand that always the function f is positive or non-negative on this interval. So if you say that the first point A is point of discontinuity, excluding A, for every point on the interval, the function f takes the non-negative values. F is greater than or equal to 0, f of x value. If the function takes negative values, we should apply the comparison test for minus f. Please take a note of it. Now, the first comparison test says that if we have f and g are two positive functions on the interval AB with f of x less than or equal to g of x, with f of x less than or equal to g of x, and A is the point of discontinuity. I mean infinite discontinuity. Then please take a note of this result. Please understand the concept of infinite series, that while defining convergence or divergence, whenever you have two series, sigma un and sigma vn, we say that if you take un is less than or equal to vn, un is the given series, vn is our user defined series. If vn is convergent, then un is convergent. In other words, for taking the concept of convergence, we should take the bigger series. If bigger series is convergent, automatically smaller series is convergent. Similarly, if you say that f of x less than or equal to g of x, if you apply the integral a to b f is less than or equal to integral a to b g. So what happens? If upper integral is convergent, automatically lower integral is convergent. Clear? The ideology behind it? So please take a note of it, then I will give the second result. So here, A is the point of discontinuity we take for f. And you can say for G also. While doing the problems, we come across with that. So I say that we consider the point of discontinuity for f only. However, it's the point of discontinuity for G2. Okay? Right. So we are considering the point of discontinuity for both the functions. The same point is the discontinuity for both the functions. So can I give the second illustration, the comparison test? So the test condition which is given here, we use occasionally, not for every problem. The second comparison test, it is nothing but we call it as limit comparison test, which we will use for every problem. So it is given that f and g are positive functions on AB A is the point of discontinuity, point of infinite discontinuity you take. And you consider limit x tends to a plus f of x by g of x. And this is equal to L, which is not equal to 0 and finite. Please understand, you can come across with the limit comparison test of infinite series. There we will write like this: limit n tends to infinity, un by vn is equal to L. So there we say that both series un and vn are converge or diverge together. Can you remember this concept of infinite series under limit comparison test? Similarly here also, apart from taking limit n tends to infinity, we are taking limit x tends to a. Since there we are dealing with series, here we are dealing with functions. So f of x by g of x is equal to L. The limit is existed and it is a non-zero finite number. So both integrals, integral a to b f of x dx and integral a to b g of x dx, converge or diverge together. Converge or diverge together. And if you recollect that concept, after applying limit comparison test, to decide the nature of sigma vn, we use the p series test. Sigma 1 by n power p is convergent if p is greater than 1. Can you recollect that formula? So here also, since both integrals, integral a to b f and integral a to b g, converge or diverge together, in order to decide the convergence of the given integral, that is f, we should know whether g is convergent or not. So for that, we use the useful comparison integral. So it is given that, so to decide the nature of integral a to b g is convergent or not, we will always make use of this test. Integral a to b dx by x minus a whole power n is convergent if n is less than 1. Similarly, if you take the improper integral, integral a to b dx by x minus b whole power n is convergent if n is less than 1. So here we need to understand, if a is point of discontinuity, it is of the form x minus a whole power n. If b is point of discontinuity, it will be of the form, sorry to say, b minus x. B minus x whole power n. So here a is point of discontinuity, we should take x minus a. For b, we should take b minus x whole power n. And these integrals are convergent whenever n is less than 1. If n is equal to 1 or n is greater than 1, these are divergent. However, separate proof is there for that, but we don't need to write that proof. We simply use this condition for checking that. Okay. So if you are clear, I will go with the first problem, which gives you the idea how to solve it. And what is the value of convergent? Nothing but the limit value. Actually, here we are not at all finding the integration value, we are simply verifying the nature of convergence. In infinite series also, we will simply mention whether it is convergent or divergent. We are not finding the summation, what its summation gives, right? If you are particular about that, the limit, you can call it as the integration value. Okay. Right. So earlier we have decided the convergence and we have calculated the limit value. Here the difference is you are simply verifying convergent or divergent, but you are not finding the integration value. And if you evaluate the limit completely, that limit value will give the integration value. So let us take the problems. Problems are very easy. Compared to earlier problems, these are very easy. So let us take the first one. It is given that integral 0 to 1 dx by root of x square plus x. And we will say that you cannot find our regular integration formulas. What is integral 1 by root of x square plus x? Do you accept? Can you find any formula in integration earlier at +2 level? 1 by root of x square plus x? I think it is not, right? Okay. Now how to solve it? Very simple. Among the 2 points, which one is the point of discontinuity? Zero or 1? 0. Right. So if you observe limit comparison test pattern, always we should take common. So you are going to write it as integral 0 to 1 dx by, if you common x square there, it will be, by taking outside, it will be x into root of, or you can take it as just x outside, it will be root of x into x plus 1. Accepted? The common. So you simply take that this part as g of x. So you have f of x is equal to 1 by root x into root of x plus 1. So since this part is giving the discontinuity or undefined value, we are removing it. So you take that g of x is equal to 1 by root x. Since 0 is the point of discontinuity, we will do that limit extends to 0 plus f of x by g of x we will consider. So this is nothing but limit extends to 0, 1 by root of x plus 1. And it is nothing but 1. Please check that. The function which is giving undefined value, we are taking it as another function g. So while applying f of x by g of x limit, that function will get cancelled. For the other function, we are applying the limit. Did you get the technique in choosing g of x? Right. So for this part, the limit is 1, which is non-zero and finite. Therefore, by limit comparison test, both the integrals, integral 0 to 1 f of x dx and integral 0 to 1 g of x dx converge or diverge together. So if you are particular, for your question you can say that 0 is the point of infinite discontinuity for both f and g. Accepted? It is the point of discontinuity for both the functions. And excluding 0, from 0 to 1 in the interval, f and g both takes the positive values. F is not negative and g is not negative. The values are greater than or equal to 0. Agreed? So it satisfies the criteria of comparison test. So you should be cautious in choosing g. Generally we take the function which is giving the undefined value. Later we apply the limit. So both integrals converge or diverge together. Now coming to this part, integral 0 to 1 g of x dx is equal to integral 0 to 1 1 by root x dx. Now if you know that whether this integral is converge or diverge, automatically you can say that the given integral is converge or diverge, right? Now how to say that that integral is converge or diverge? Because earlier I have given the comparison, useful comparison integrals dx by x minus a whole power n is convergent when n is less than 1, where a is the point of discontinuity. So this is nothing but integral 0 to 1 by x minus 0 whole power 1 by 2 dx. And here 0 is the point of discontinuity. So you can assume that integral here. So always integral a to b g of x dx integral will be compared with this type of notation. So as per comparison integral, since the power is 1 by 2, which is less than 1, this is convergent. Therefore, given integral is also convergent. That is the conclusion. So how do we write an exam? We have integral 0 to 1 g of x dx is equal to integral 0 to 1 by root s dx, that equal to integral 0 to 1 by x minus 0 whole power 1 by 2 dx. Since the power is less than 1, it is convergent. Therefore, given integral is also convergent. That is the conclusion. Okay. Did you get the idea? Any other cross questions? Is the approach clear to all? So I want to take one more problem on this model. Then I will wind up our session. Tomorrow we are going to solve all the improper integrals based on these comparison tests and other tests. And with regard to examination point of view, you can expect questions from this part. Problems based on the comparison test, and you can expect some little problems which are somewhat complicated too. Okay, can I proceed? Right. So the other problem which I want to take is so integral 1 to 2 dx by 1 plus x into root of 2 minus x. Yes, here we are not finding integral value. We are simply saying that the integral is giving a finite number or not. That's it. Please understand. It is just like verifying the convergence of infinite series. Because for the earlier problems, we have evaluated the integral. Because you know the primitive of the function, the integrand. You know how to integrate the integrand. The primitive value is known to you. Here the primitive value is not known to you. On the whole, you can say that it is going to converge or diverge. That's it. For some functions, we can be able to find the limit, and you can say that the integration value is this. For the rest, we simply say that this is convergent and this is divergent. That's all. Okay. Is it clear for you? Right. So, in the interval 1 and 2, which point is giving the infinite discontinuity? 2. So, the function here is root of 2 minus x. That function we should take it as g. So, we have f of x is equal to 1 by 1 plus x into root of 2 minus x. You take g of x is equal to 1 by root of 2 minus x, and 2 is the point of infinite discontinuity. So you are going to apply the limit as limit x tends to 2 minus. So for the lower limit, we apply plus. We use the symbol plus in the limit part. For the upper limit, we should use minus symbol for the limit part. So f of x by g of x is equal to limit x tends to 2 minus 1 by 1 plus x is nothing but 3. Since it is finite non-zero value, both the integrals converge or diverge together. So if you consider the integral 1 to 2, 1 by root 2 minus x dx. Since 2 is the point of discontinuity, you can assume this integral as 1 to 2, 1 by 2 minus x whole power 1 by 2 dx. It is just like integral a to b dx by b minus x whole power n of the form. So if you compare the power is 1 by 2, which is less than 1. Hence, this is convergent. Therefore, given integral is also convergent. Okay. So at this moment, I want to conclude my discussion. And tomorrow we will meet with the other problems, which will be interesting for you. And majority of the questions are previous year questions here. If once you know how to solve them, it is very easy to discuss. So that's all for today's session. And we will meet tomorrow. If any other queries you have, you can ask. So is the explanation sufficient for you for improper integrals, or do you need more? Right? So we will meet tomorrow for the rest of the part.